Okay, now we are working with question 3, and we are told that you are working with a quadratic number pattern that has this form, and then we are told that the first term is equal to 1, and the general term of the first difference is given to be 4n plus 6. So how do you tackle such a problem? Let me guide you on how can you solve this one. So let us go for a solution. Okay. In our solution, 1, we have to take note of the information given to us. We are working with a what? A quadratic number pattern is equal to an squared plus bn plus what? Plus c. And we are told that the first term is equal to what? Is equal to 1. And mind you, you know that when we work with a quadratic number pattern, okay, we have t1 of which is equal to a plus b plus c. How do we reach here? You say t1 is equal to a into 1 squared plus b into 1 plus c. As the result, you have t1 being equal to a plus b plus c. Meaning, this is the information that we have. A plus b plus c is equal to 1. This is what we know. Okay. And see, now we have many unknown variables. A is unknown, B is unknown, and C is unknown. So we can't work with these, but we will see where will this thing lead us to. But we are told that the general term of the first difference is given by 2n plus 1. Remember, between T1 and T2 and T3, okay, let me just make 4 terms. Between T1 and T2 of the first term, the first sequence of which a quadratic sequence, we have T1 on the first difference. And between T2 and T3, we have T2 on the difference. And then here we have T3. And mind you, we know that when we work with a quadratic sequence, this is the one that is common, of which is the second common difference, and it is derived to be 2a. Okay, so now let us work with this. If we can get these 3 terms, since we know the general term of this first difference, of which is Tn is equal to, they say Tn is equal to what? Is equal to 4n plus 1. It's 4n plus 6. Okay. So meaning if I want term 1, I'll be having 4 times 1 plus 6, of which is 4 plus 6. So it's T1, of which is equal to 10. But remember, don't confuse this T1 and this T1. This is T1 for the first difference. This is T1 for the quadratic sequence. So we are looking at the first difference since the general term given to us is referred to of a first word difference. So if I can know T1 and T2, that can make my life easier for me to get A, since the first question requires me to find the value of A. So it will be 4 times 2 in this case plus 6. And then 4 times 2 is 8, 8 plus 6, and then the result here is 14. Okay, so now I know that when I'm looking at this, T2 minus T1 is equal to 2A. So it will be here T2 minus T1, in this case is going to be 2A, where T2 is 14, minus T1 is 10, of which is 2A. This one will give me 4 equal to 2A, divide both sides by 2. So the value of A in this case is equal to 2. Okay, meaning I did manage to solve the first question, but remember, marks are as little as 2 marks, but I just extended this information so that it can make your life easier. It can make your life easier. Okay, now look what are the benefits of what I did. It will make my life easy when I have to answer the following questions. So, okay, I was working with 3. Okay, here I will say this is 3.1.1. That's where the problem starts. And then let me go for 3.1.2. 3.1.2 requires me to get the formula for Tn and it's 4 marks. My life is easy now. I know that the value of A is 2. And what is the remaining unknown? It's B and C. What I know that this term here, of which is T1, is equal to 3A plus B. And this one, I told you that this one is equal to A plus B plus C. So I'll just go straight here. I'll be saying 3A plus B is equal to T1 of the first difference. Remember, T1 in this case is what? Is 10. Is 10. I think, yeah, we did got 10. Is 10. So we have 3A plus B is equal to 10. And I know the value of A. I found it to be 2. So it will be 3 times 2 plus B is equal to 10. So 6 plus B is equal to 10. Then B is equal to 10 minus 6, which makes B to be equal to what? 4. And now I'm going to use this information that I was told earlier, that the first term of the quadratic sequence is 1. So now I'll be having what have I done? I'll be having A plus B plus C to be equal to 1. And I know the value of A now, that the value of A is 2 plus the value of B is 4 plus C is the only unknown is equal to 1. So when I add the 2, I get 6 plus C is equal to 1. Then C is equal to 1 minus 6. As the result, C becomes minus 5. Am I done? No, I have not yet answered the question. The question says I should find the general term. So now I conclude by saying Tn is equal to An squared plus Bn plus C, where A is 2 to N squared plus where B is what? We said B is 4 plus 4N and C is 5 minus 5. So this is the complete solution for the problem that we are tasked to answer. What is next? Here is the one. This is the one. 3.2. We are given the series, and the series is of the form that it is in the bracket. The term number 1 is 1 times 2, plus term number 2 is 5 times 6, plus term number 3 is 9 times 10, and plus term number 4 is 13 times 14, plus blah, 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 plus 81 times 82. So I'm required to write the series in sigma notation. And I'm told that it is not necessary to calculate the values of the series, the value of the series. Okay, so I have to write it in a sigma notation, but I don't have to come up with the complete solution for it. Okay, how am I going to write this? 1 times 2. You see, it seems tedious, but there's something we can do about this. If you can treat, you see, it's 1 times 2. If you can treat 1 separate from 2, 5 separate from 6, 9 separate from 10, 13 separate from 14, 81 separate from 82, there is a pattern that you can discover. Let me write this as 2 different terms. Okay, so 3.2 is 3.2. Okay, look at this again now. Let me even use another color so that you will see that we are now doing a serious things. Okay, let us use this one. 3.2. Okay, this is the series that you are working with. Plus, and it's 5 times 6, plus, and it's 9 times 10, plus 13 times 14. Okay, 13 times 14, plus, blah, 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 plus, and then we have 81 times 82. Okay, if we can treat these first terms separately, I'll just even use different colors so that you don't get confused. Let us look at this one. We have 1 plus 5 plus 9 plus 13 plus what? 81. Okay, let me go for another color now. Let me use blue. And then we have 2 plus 6 plus 10 plus 14 plus plus 82. Okay, let us look at this one. If you say T3 minus T2, it will be 9 minus 5. You get what? You get 4. And if you say T2 minus T1, it will be 5 minus 1, and you get what? You get 4. So you see, you have a common difference here. Okay, we are not done with this one, but let's just go for this one now. Okay. Now look at this one. If you say T3 minus T2, it will be 10 minus 6, of which is 4. Again, okay? And if you say T2 minus T1, you'll be saying having 6 minus 2, of which will also give you 4. Okay, so there's something common with these two series. They are all arithmetic. 1, 2, they all have the common what? Difference. But the difference is that for the first one, it has a first term that is 1, and the second one has the first term that is equal to 2. So how are we going to maneuver things around that? It's fine. Don't worry, don't panic. Now, let me start by this one. Let me start by the first one, the one that I chose to be the first one. Okay. I have Tn is equal to a plus into n minus 1 times dy. I know that I'm working with an arithmetic series, by the way, so I can get it general term by using an arithmetic equation. So Tn, in this case, the first term is what? Is 1 plus into n minus 1, and the difference is 4. So Tn is equal to 1 plus, it's 4n minus what? Minus 4. So Tn is equal to 4n minus 3. Okay, I'm done with this one. Let us go for the other one. The other one says that, let me use its color so that I don't mix them. So the other one say Tn, okay, is equal to a plus n minus 1 times dy. It's because it's arithmetic, by the way. And then the first term on this one is 2, not 1. So now I'll be having 2 plus into n minus 1 times the common difference, of which is 4, of which will be 2 plus 4n minus 4, which is something that will give us 4n minus 2. All right. Look here. I have 4n minus 3, I have 4n minus 2. These two general terms are not the same. How am I going to tackle this? Look carefully. I'm now working with what? With the series. When we talk of the series, we talk of summing. What is it that we are summing? We have to write this thing in terms of a sigma notation. For the first one, I'll be summing values. All right, before I even go there, I cannot just jump to conclusion. Okay, let us go back here. I know last term here, it's 81 and 82. So meaning on this first series, I know the last term. The last term is 81. On the second series, I know the last term is 82. How is this thing going to guide me, man, on a way forward? How is this thing going to guide me on a way forward? Okay, it's fine. Let me find what the last term of this one. Okay, let's just go here. 4n minus what? Minus 3. So taking this one to the other side will be 81 plus 3 is equal to 4n. So I'll be having 84 equal to 4n. Then I have to divide this by 4. So divide by 4 both sides. So 84 divided by 4 will be 21. So 21 is equal to n. Okay. So same thing applies here. Now let me use another color so that you don't lose me. So now I'll be having 82 is equal to 4n minus 2. Taking this one to the other side, I'll be having 82 plus 2 equal to 4n. So I'll be having 84 equal to 4n. Then divide both sides by 4. Then the value of n will then be equal to 21. All right. So now I know number of terms that are being summed here. So in this case, it's a summation from I equal to what? We are starting from the first term up to what? Up to the 21st term. Okay? Yeah. Because when we want n, it has to be top minus bottom plus what? Plus 1. So in this case, if top is 21 minus bottom is 1, then plus 1, you see the value of n will come back to be 21, by the way. So that is why I just wrote it like this. So don't get confused when you see me writing it like this. Okay. We are not there. Okay. So we are summing from 1 to 21 terms of what? Of 4n minus 2. So you see, this is the expression of this one in terms of sigma notation. Now let me go back to the other one. I'm going back to another series. Okay. So as for this one, again, is 21, meaning the very same thing that happened here will also happen here. So I'll be summing from I equal to 1 up to 21 of what? Of 4n minus 3. All right. Now, pay an attention here. When it comes to the summation, you know these terms are being multiplied term by term. How can I make life easy to make it look like the way they are being arranged? Okay. So I will be summing from I equal to 1 up to 21 because they go in pairs. So it will be 4n minus 3 times what? Times 4n minus 2. So whenever I perform all the calculations, this is how this series was being discovered. Yeah, it was a long journey, but I hope you will find it fruitful and understandable.